Hello all, welcome back from our previous talk where we discussed the theory analysis, simulation, and overall performance of operation amplifier as an inverting amplifier. This time we are going to talk about the op-amp as a non-inverting amplifier. So let me write here non-inverting amplifier. So how this video is going to be different, we will derive an expression for the gain, that is a closed loop gain. Remember, I am referring to AOL as open loop gain, and I'm referring to ACL as a closed loop gain. So when I say closed loop gain, it is with a negative feedback. Usually I will place the negative feedback, and it is called negative feedback because I'm taking the output back and connecting it back to the negative terminal of the op-amp. So here you see a circuit is available where I have an amplifier as shown with an open loop gain AOL. Usually it's a macro model that I have picked up from the circuit simulator library. Uh, Please refer back to the previous video on inverting amplifier to understand about what is macro model, how to use it, how to take it from the device library, and right clicking on it gives you access to change the parameters about its open loop gain, gain bandwidth product, offset, differential input resistance, etc. So that part we have discussed in our previous video. So if you want those details, refer to that. So now you have an amplifier with the gain AOL, and then it has a negative and the positive input. We call this terminal as a small v2. And just to avoid the confusion, let me call this voltage source as V in, because I am referring V1 and V2 as the negative and the positive terminals of an amplifier respectively. So I am now set with the understanding. I am saying the voltage at the positive is small v2, voltage at the negative is small v1. I have external signal source, maybe voltage or current, with a DC value of 1 volt connected at the positive terminal of the amplifier, and the resistor R1 is one end is connected to the ground, second is connected to this node, which is at V1. I have a feedback resistor of value 10K. I call it RF. One end is connected to output, one end is connected back to V1. Now I know the amplifier output V out is gain times VID, which is gain, closed loop gain, that will be set up by the resistors. I am going to find the expression for the gain. And this is VID is your V2 minus V1 or V1 minus V2, let's say. Okay, so it's in the magnitude, we'll say V1 minus V2. Let me write it properly so that no confusion and the writing is clear for the viewer's understanding. So V out here would be ACL and multiplied by V1 minus V2. So this, I'm taking the magnitude of that. Now, I am supposed to find an expression for ACL, which is the closed loop gain. So what I see here, the V2 is nothing but V in, which is an external input I am applying. All right. So I see that there is a current from V1 flowing through R1. I call it, let's say, I1. And then there is this current flowing through RF. I call it as IF. And at this node V1, I am supposed to apply KCL, that is Kirchhoff's currents law. So let's do that. I have a value of I1 is equal to V1 minus 0 divided by R1, and value of IF is, let's say, V out minus V1 divided by RF. And applying KCL gives me I1 is equal to IF, which is the outgoing current is equal to incoming current. Remember, I1 is outgoing, IF is incoming. So I write V1 divided by R1 is equal to V out minus V1 divided by RF. Simplifying that gives me these values, R1, V out minus V1, and this is V1 times RF is equal to V out times R1, and minus R1 times V1, right? So how I can actually solve this out? Let me just do that. Right, so I can write RF over R1 is equal to V out minus V1 divided by V1, just manipulating these equations, and then I see RF over R1 is equal to V out by V1 minus V1 by V1, which is equal to V out by V1 minus 1 RF over R1. And just writing over here, I see that V out divided by V1 is equal to 1 plus RF over R1, right? And V1 is this potential. If I assume the gain is very, very high, which is AOL, that forces the voltage at V1 to be equal to voltage at V2, and voltage at V2 is V in. Therefore, I can write V out divided by V in, which is this voltage source, external voltage source, is equal to 1 over RF over R1. So that's the approximate expression for your voltage gain. You see, we are assuming that the open loop gain is pretty high, right? And that's the advantage of an op amp. Now having explained the derivations in a very systematic way, we have derived. Let us set the value of resistors like 10K here, 1K here. So the gain is about 11. So if I apply 1 volt DC, I should have 11 volt at the output. To verify that, let us perform a basic simulation of operating point. So what I'm doing here, I have this .op command already there, just from the previous video. I will enable it by right clicking here. I see that .op is disabled, but now I put dot, click OK, and this command is enabled now. You see here .op. I click simulate, and I don't want the yeah, so your AC analysis is enabled here. So right here AC, so we don't want AC. So right now just check if the DC voltage source is enabled here. Right click, it is DC voltage source, and the AC analysis, right click and disable this also with this one, and then we'll just now rerun the simulation and we'll check. So now we are done. So run the analysis and see the response. That's good. And we see now I have explained you the theory. So let me get rid of all the drawings. That's clear. And now you see I have this voltage at the V1, which is 0.99, which is right here. So because of the gain, open loop gain of this amplifier, which is set in the macro model to be 1 mega, or I think 10 mega. Let us check it. Let me right click here. Before that, I need to close this to show you how much gain I have set up. Right click, and you see I have set up the 10 mega OVL is the open loop gain. And with that, I will show you now. This is like 0.99 volt. Here you see there is 0.99 volt at the node V1. And why that is coming? Because the AVOL is 10 mega, very high. So that forces this voltage at V2, which is V in, come at V1. So approximately equal. Then voltage at node NO1 is 1 volt, which is the voltage at small V2. Then you have output is about 10.999. So what we calculated in theory is 11 volt is correct. And other things are your current through resistors and current inside the op amp terminal. That's good. That's a good approximation. Now we'll run another analysis. Okay, so with that said, I will now encourage you all to repeat exactly all those things what we did with inverting configuration in our previous video. I'm going to paste the link of that video in the description. So right now you will see I have run the DC sweep analysis, transient, and the AC sweep, and you for the inverting mode. Now the task for you is to do all those for the non-inverting case and write your answers or in the comment sections. If you like this video, click the like button, share it with others for a wider reach, subscribe to the channel. I encourage you to do that. And till then, stay tuned. Wish you happy learning.